Hey everyone, in this video we're going to cover up what's the full screen shader graph, and we're going to practice it with a colorblind filter, which I think every game should have this feature. So first we need to start with what is a full screen shader graph. If you worked with other shaders like lit shader, unlit shader, you know how shaders work a little, yes, but a full screen shader is a shader runs across all pixels in the screen. Like when we have a lit or unlit shader, we create that shader, prepare that shader, and create a material from that shader. And like we want to change a object's texture with a shader, so we add to our shader's material to that object, and boom, objects color, objects bloom, objects vignette changes. But here in full screen shader graph, when we create a material from it, that material not only affects one object, it affects all screen. So before we start, I want to warn you about version problems. You need a URP project, and your Unity version needs to be 222 or newer. I'm using now 6000.0.60f1 if you want to create the project with the exact version as me. And as I said, your project needs to be an URP, Universal Render Pipeline project, but it doesn't matter 2D, 3D. So first we start with creating a full screen shader graph. Here I'm in assets, let's say create shader graph, URP, and full screen shader graph. And I'm gonna name it color blind filter. Let's open it up, and here's our screen. So, okay. Now, here's our property screen, and here's our node screen. If you worked with shaders before, you can skip these parts because I'm explaining it like you never worked with shaders before. So I'm gonna add timestamps to the description. You can jump these timestamps to fast in your process. So here we need a property. Why we need a property? Because in the game, you can see we have three main colorblind versions. I don't know how to colorblind types. And these are Tritanopia, Protanopia, and Deuteranopia. But what are these, you can ask? I don't know well either, but according to my research in the internet web, Deuteranopia is people cannot differ red and green, also red and pink, green and pink. And in Protanopia, people cannot see red. And in the Tritanopia, people cannot differ blue and red, blue and pink. So here are four choices and three colorblind types: Tritanopia, Protanopia, and Deuteranopia, which we all covered up. So back to our shader graph. We need a property to choose our colorblind type to apply our effect. So here I'm pressing plus, and here in the keyboard there is an Enum option. We choose our colorblind effect with this enum, which will be named colorblind mode. And when I click it, a screen like this appears here. Watch out for characters, like try to make them compatible. And here our first value is none. Second value is Tritanopia. I hope I'm writing that correctly. Protanopia. And the over Protonopia. And the last one is Deuteranopia. Okay. They're correct, right? Yeah, they're correct. So this is our reference. We're gonna need it. So don't forget it. And here's our colorblind mode. So property part is over. Now we're gonna create our shader tree. First, we're gonna need a node to get the screen color, which will be URP sample buffer. This node's output will return our complete screen color. So this is an important node for us, but we need to change its source buffer to the bleed source. Okay, this is done. Now we need to change our color, screen color, to create a colorblind effect. So somehow we need to change our screen color, right? How can we do it? We're gonna do it with color transformation matrices. What are these matrices? These matrices are used to change an RGB color to anything you want, actually. And for the colorblind types, there are some transformation matrices too. And we're gonna use these values to change our RGB color to another RGB color. How can we use a matrix to change our color? We are using matrix multiplication. Our RGB color multiplies with our color transformation matrix, and boom, here's our new color. How can we do this? We can do this with adding a new channel mixer node. I'm adding a channel mixer node here, and another channel mixer node here, and another channel mixer node here. The first one is Tritonopia, second is Protonopia, and third one is Deuteranopia. We're gonna get our output here, here, here. Okay. Now our all channel mixer inputs are set. Now we need to insert our color transformation matrices into these channel mixers to apply our effect. In here you can see R, G, and B. R represents upper row, G represents middle row, and B represents the lower row in our color transformation matrix. I'm gonna put the matrix values in the screen here. You can see them on the screen, or you can, if you want, search them on the net. And while I'm applying these values, I'm going to speed up this process. Okay, our color transformation matrices are ready. Now they are changing our color in this node, but we need to choose which one we're going to use to create our colorblind effect. So we need our enum here, and I'm dragging it here. So none represents no effect. So I'm dragging our screen color here. And as you can see, input format changed. And first one, as you can remember, it was Tritonopia. So here Tritonopia, here Protonopia, and here Deuteranopia. And our output is our base color. You can leave the alpha like 1, or you can drag another here, another branch here and connect it to alpha. So here is our shader graph, our URP sample buffer, our channel mixers to multiply and transform our color, and our enum selector here, and our base color. Now I'm gonna save the shader graph. Don't forget to save your shader graph. And let's stop the game. Now here I'm right click to your shader, select create, and here select material. I'm gonna name it colorblind filter again. Oh, sorry, colorblind filters. Okay. And as you can see here are enum and our colorblind types. We're gonna change it and see the result. But before that, we need to assign our material to our renderer. And how can we find our renderer? If you are using a newer version of Unity, here in the assets, in this there's a settings folder, and in it there's a renderer 2D and universal RP. But if you can't see your settings folder here, click the search bar and search universal, and you're gonna find your universal renderer. And in the universal renderer inspector screen, you can see a renderer list here. This renderer list directs you to your first renderer 2D. If you didn't add another renderer to your game, your camera 100% uses this renderer, so don't worry. And here in the inspector screen again, there is a add renderer feature here. I'm gonna remove this and add renderer feature. Click the add renderer feature and you can see a full screen pass renderer feature. Click it and add your component here. And by default, it has an inverter material, so it inverts all the colors. We don't need that. We're gonna assign our colorblind material here. And you can change its name. I'm going to change it to colorblind filters. And injection point should be after rendering post-processing. And other settings are okay. Now, since we add our material, let's test our game. Hit the play button. And here our material is none and our colors are normal. Let's select Tritanopia. And boom, as you can see, in Tritanopia, except red, all colors changed. Let's select Protonopia and again changed. And Deuteranopia. But as you can see, drop down doesn't change. Maybe you can say it's because it's black and white, but let's try it like this. Here in the UI, create an image. Let's say test and let's make it red. Okay. And in the game, it looks like this. And when I start the game, and when I change the Protonopia, as you can see, red becomes green, but this red didn't change. It's because our injection point settings, it should be affect the screen after rendering post-processing, but since we add our canvas after rendering post-processing, it didn't affect the canvas, so we need to make canvas screen space camera and assign our camera to it. Now, as you can see, UI elements are also changing color. But in the game, how can we change this so player cannot go to the inspector and change this color? So we're gonna add our drop-down box script and solve it too. Okay. To make it a game feature, not an inspector feature, you're gonna need a script here. So I'm here, scripting and mono behavior script. And color blind filter, I know again, but this is our subject. So I'm opening the script now. So here I'm deleting all of that. Okay, now we can start to write our script. First, I'm going to zoom in. Okay, now first we need a reference, which is our material. So sales ice field, private material, color blind nuts. And also we need our drop-down box reference, private TMP, drop down. And last, we need our keyword references. What are these? These are here, and you can see in the enum, there is an enum reference, and for the entries, for each entry, there is a reference suffix. So for example, if I wanna reach Tritanopia value and change its value, first I need to enter enum reference, which is colorblind mode, and merge it with Tritanopia's reference suffix. Let's do it here. First, we need to define the keywords, which is right, keyword, I'm sorry, local keyword, none. Our first option, private local keyword Tritanopia, private local keyword Protanopia, and private local keyword not contributor Protanopia. And we also need to initialize these keywords. What I mean by initializing, it's we're gonna get their values and assign them to do these variables. So private void initialize keywords here none. We need to do this process 4 times. None equals new local keyword. First, we need our shader, which we can get from our material, colorblind material.shader, and here's the important part. We need to enter our reference. So first is colorblind mode, enum reference, and merge it with the entry reference, like this, colorblind mode and node. So as I said, 4 times, Tritanopia, Protanopia, Deuteranopia. And here's Tritanopia. I hope I'm writing correctly. Protanopia and Deuteranopia. Okay, I guess they're correct. So we need to call this function from which wait. Well, as I said, awake. We need more. We need to assign our drop down to. So drop down, no, drop down, false. Let's component template drop down. And if drop down is not null, drop down dot on value change dot first remove all listeners, then drop down dot on value change dot add listener. We need to create a new method public void on value changed index here on value changed. Okay, Now here, first we need to set our all keywords like non, tritanopia, protanopia, and deuteranopia to false. Because if we change them before and we want to change them again and we did it without resetting them, two of them, three of them can be true at the same time, and we don't want this. And to prevent this error, before we start our process, we reset all of them. How can we reset them? We're gonna use set keyword methods with our material. I'll write material dot set keyword. First, we're gonna enter our keyword, which is none, and second, the value false. And we're gonna open that 4 times, 3 times, okay. Proton, okay. Deuteron, okay. And after resetting them, let's create a switch. And here, according to index, we know the line none first, Syntonopia second, Protonopia third, and Deuteranopia is fourth in our drop-down box. So case 0, we need to make none true. So colorblind material dot set keyword none true and break. Let's copy this 3 times. And 1, 2, 3. 3 times Nopia, Protonopia, and last one is Deuteranopia. Okay, now our script is ready. Let's zoom out a bit. And here you can see our methods and our references, all of them here. Let's go to our project, see our drop-down box, and I'm gonna show it again. Add component, colorblind filter, pass your material to colorblind material field here. You don't need to change anything. We already had to already changed part. Just be careful about the options here. There should be 4 options. First should be none, second should be tritanopia, third should be protanopia, and fourth should be deuteranopia. Let's test it out. Okay, here none is chosen. Let's choose tritanopia. Okay, everyone's changed. That's great. Let's choose protanopia. Okay, everyone's changing. The last one is deuteranopia. Protanopia and deuteranopia looks nearly same, but as you can see here, it's changing a little bit, but it's changing. And it's our little demo for creating a colorblind filter. I hope you enjoyed video. If you have any questions, any recommendations, you can comment down below. And sorry for my English. I hope you understand well. And as I said, if you have any questions, you can ask them in the comment section below. Thanks for watching.